Hello everyone, my name is Tim Wool. I work for EPA Region 4 in Atlanta, Georgia. Today I'm going to just talk about how to deal with temporal and spatial data to support model application. I'm going to talk a little bit about using different scripting languages and the utility of them. And then I'm going to share with you two programs that are free of charge. One is open source and then one is just readily available from Microsoft. Okay, let's just go through some of the objectives that we hope to accomplish during this webinar. The first one is I just want to give you an overview of using a scripting language like R and Python to support modeling. Talk a little bit about how R and Python would fit into a workflow for applying watershed and water quality models. I'll give you a couple of examples, one with R where we'll be retrieving USGS flow gauge data and processing into a form that we can analyze and look at pretty quickly. I'll show a Python example where we process watershed model output and put it into a form that can be used by a water quality model. And then I'm going to spend a good bit of time talking about an open source program that you don't have to have any programming skills whatsoever to use, where you can import data and process it into a form that you can graphically analyze the data, do data summaries and reports, and actually look at them in a spatial component. That program is called the Water Resources Database, WRDB. And then lastly, I'm just going to introduce you to a Microsoft project called Power BI Desktop, which again, you don't need any programming skills to use to analyze data, both spatially and temporally. And we'll talk about that towards the end. All right, let's just talk a little bit about when and why to develop programs and scripts. Some things that you need to think about to see if it's really worthwhile to do. You know, surely if you have a repetitive process that you're doing over and over again as you go from one project to another, you certainly would want to look at scripting to automate that process. If you're processing large amounts of information, both R and Python are very good at handling large amounts of information that can be processed into different forms, calculations made, so on and so forth. Or if you have to make detailed calculations where you're making, units conversions and things like that, or summarizing data based upon some kind of criteria, you may want to do a programming script language on that. And really, the reason why the scripting and programming languages are a good thing for this is, once you have the scripting QA and QC'd, you can be used over and over again with confidence. And then lastly, if it's going to save you time in processing things. And we'll talk a little bit more about that in a second. Okay, so just should you invest in learning R or Python? The pros we just kind of talked about. If you've got a repetitive process, it's going to save you time. Once this process or scripting has been QA/QC'd, it's reliable and it can be used going forward. These scripting languages have access to various statistical and graphical tools that if you were trying to write yourself or program even into something like Excel, it could take a good bit of time. You could process the data into forms needed for evaluation and modeling. And then for both R and Python, YouTube is just a treasure trove of places to go to see how to do things with these two scripting languages. The cons, it does require some basic programming skills and it's got a steep learning curve, especially for things like R. But, I think the benefit is that once you learn it, it's going to let you be more productive. Okay, so let's just talk about, how do you determine whether it's worth investing the time to one, learning a scripting language, and two, writing a program to deal with a process. One of the first things that you probably need to do is you just need to analyze your workflow, whatever it is, for whether it's a modeling project or evaluating water quality monitoring data. Are there any repetitive steps that could be automated by scripting? Are you processing large amounts of data where it may be more advantageous to use a scripting language? And whatever you do here, hopefully it'll save you a substantial amount of time, because if it's not going to save you any substantial amount of time and it's a one-off, yeah, you could use it as an opportunity to learn how to write scripting language components, but it may not necessarily be needed. Okay, what I'm showing you here is our workflow in Region 4 when we're doing nutrient modeling for a riverine system. And our typical modeling approach would be using a watershed and a receiving water quality model to pretty much simulate the whole watershed. And we have analyzed this workflow through the years and have added scripts or programs at key points that allow us to streamline our process and do things quicker. So anywhere in here, you can see that where we come up with the script is basically anywhere you see one of these stars. And I'll just briefly talk about each one of these stars to begin with. But, you know, we've done a webinar before on basins and stuff like that. Basins is typically our first step for starting to acquire some data. And in it itself has a whole bunch of scripting in there that automates downloading data. But we have tools that have been augmented for doing watershed basin delineation and building the LSPC network. That work was done by Glenn Fernandez. Glenn is also responsible for writing a weather processing tool, which we highlighted in a previous water modeling work group webinar. But this processing tool can gather meteorological data from several sources, process it, fill in missing data either using a statistical or stochastic approach, and then write out a file that could be used by HSPF or LSPC. John Davis in the modeling on the modeling team has written R scripts to process point source data, to fill in gaps, or to interpolate between different nutrient species based upon the data that we have, which is crucial when it comes to doing nutrient modeling, because we typically don't have all the data that we need straight up to go into a water quality model. Glenn Fernandez has also developed an LSPC plugin that can actually create a complete LSPC data set through a set of scripts using information that was downloaded through basins and weather data that was processed through the weather tool. There's another a script or a plug-in to basins that you could use to build a stream network for WASP. It takes into account all of the data that was downloaded in basins like the NHD, the National Hydrography Data Set coverage to generate a WASP network. And then ultimately, there are a whole bunch of tools that will take data from WRDB and process it into a form that can be used by a water quality model like WASP or a watershed model like HSPF and LSPC. And then we have a series of scripts that were written by John Davis for doing model calibration, which will process model output and combine it with measured observed data to come up with a set of calibration metrics that we use during our calibration process. And that process will be demonstrated tomorrow. Okay, now I'm just going to show you a couple of examples of an R script and a Python script. I'm just going to give you a brief introduction to what the script does and then just demonstrate how it works and show you the time savings that we gain from it. This first script I'm going to show you, you've seen a demonstration of this previous in this workshop where an R script goes out to the USGS servers and downloads data. In my case here, we're going to just demonstrate downloading USGS flow data. This R script was developed by John Davis at EPA Region 4, and it's just part of our scripting to aid in streamlining our workflow. It uses the USGS data retrieval tool to access and download the data. You've seen that before. Our twist on this is it's actually going to process and convert the data for the water resources database and also put it into a form that can be used by the models. And then I just want to point out, as you start looking at scripting languages, you should be paying attention to the various integrated development environments that are available, because it makes these tools a lot easier to use. The most prevalent one that's used for R is called RStudio, and it's a free program, but it's pretty much a comprehensive development environment that helps you with R programming. Okay, so the first script I'm going to show you is an R script for retrieving USGS flow data. We've already seen one demonstration of this using USGS's data retrieval tool. And this one is just a little bit of a twist on it to work better with the EPA Region 4 flow process. In our case here, we're going to actually process the data into a form that can be brought into the Water Resources database. So in this script folder labeled NWIS, there's several things I'd like to point out to you. The first thing is that there is a user manual in here that's actually fairly comprehensive that John Davis put together that will help you use this tool fairly easily. The other thing I want to point out to you is that a lot of our scripts that we use in Region 4, we rely on Excel sheets to become the user interface to provide that. We don't really spend a lot of time developing user interfaces because these scripts kind of are running in the background, and it's more important to get the data processed than to make them look pretty, so we just use Excel. So in our case here, these are the gauges that we're going to be pulling the USGS data for. We are not going to pull any water quality data. If there was water quality data at some of these stations, we could just check, put an X in these boxes and pull it down. But what we're going after is just the average daily flow. We check and turn it on. We set the time domain, so we're going to go from 1995 through, as far as they have in 2021. We set the time zone, so any time calculations that we make are appropriate. And then the next thing that we would do is we would just go ahead and load the R project. And as I said, leading into this thing, that we're using RStudio here. So I'm just going to load this R project into RStudio, and it'll bring in what we need to run this package. So the only file we really need to bring in, or script, is this master one. And once it's loaded over here, we can go ahead and hit source. And what it's going to do is it's going to open up that Excel lookup table, get the gauges that it wants to pull the data from. It'll go out to the USGS server and download all of those gauges so that we can have the data. It's also going to do some analysis for us and create some graphs. So it's done at this point. I'm going to go back to my File Explorer, and then if I just click on Plot, I'm going to turn on a preview here. You can see in here that it's pulled down each one of these gauges that we asked for. Now the USGS serves their data up in cubic feet per second. Most of the models that we use are metric, so cubic meters per second. So what's happened here is we've downloaded the cubic feet per second and then created a second graph of cubic meters per second for each one of these stations. And you can see it's for a full period of time. The other things that it has done in the background is it has created a set of files that we will go ahead and we will read into WRDB. And then lastly, there are some stats that were generated from the download that you can look at just to see, just to check and make sure that the data is appropriate. So our next steps in this, which we'll do a little bit later, is we are actually going to go ahead and import this data into the Water Resources database and plot it and do some simple analysis. Okay, the first tool I'm going to take you through is the Water Resources Database, WRDB, which is a free open source tool that's actually very mature. It's been around for a very, very long time, and it has a lot of capabilities for doing a lot of things that we need to do day to day, but you would not have to know any type of scripting language to use it. WRDB was originally developed in 1994 by Chris Wilson with Wilson Engineering. And it was developed to support the Georgia EPD and EPA Region 4, specifically to support a water quality modeling project for the Chattahoochee River. The primary person at EPD wanted a tool that could keep track of where data came from, where it ended up, any calculations or assumptions that were made. It was basically developed to support model development. So it manages time series for modeling, and it also manages monitoring data for model calibration. The objectives of this portion is just to give you an overview of WRDB's capabilities, give you an understanding of the underlying schema or the database structure. This way you can interact with it a little bit better. We're going to build a project and we're going to import some data. And actually the data that we're going to import is going to be the data that we downloaded using the R tool in the previous section. We're going to go ahead and analyze some of this data using built-in reports, which will allow us to summarize the amount of data that we have. We'll look at time series graphs, and then ultimately we will go into a GIS component and look at our data where it actually resides within the river itself. Probably one of the most confusing things about using WRDB to a lot of people is the supported database frameworks. And WRDB is the same no matter which one of these frameworks is used, but it's specific to that database type. So if you're a Microsoft Access person, if you pick an Access file structure for your WRDB project, you would be able to look at that data both in WRDB as well as Access. Or if you wanted to do it in SQLite, you can. It's the same thing. It's just a different file structure. But these are the database structures that it supports, and you'll notice that there are some that are just standalone, reside on your machine, and then there are also some client-server ones like Oracle, MySQL, and SQL Server. All right, let me give you just a little bit of insight into the WRDB schema, because it's kind of important to understand this a little bit when you go to import data into it. There's a lot more relational things that go on in WRDB amongst multiple tables, but the three tables that I'm showing you here are the bare minimum you need to do to get data into WRDB. So the first one is the stations table, and the stations table is exactly that. That's where you put information that is associated with defining where a sample or model output is associated. And then you have to have a unique station ID. You can give it a name, latitude and longitude if you're going to do any of the spatial components of it. And you'll notice that the gray asterisks, these are not required fields. The next table is the parameter table, which is basically, the parameter code, whatever it is that you're hoping to store: dissolved oxygen, total nitrogen, bacteria concentration, so on and so forth. And again, the only requirement here is the parameter code, and again, it's a unique code. And then you can give it a name in units. And then lastly is the actual data table. And in WRDB, you could break up the data tables into multiple working tables, so you don't have to store it all in one table. But the fields that are shown here, 4 of those 5 are definitely required for it to be a valid data point for WRDB. The first one is a station ID, which is related back to the station table, and it's a unique station identifier. It has to have a date timestamp associated with it, which basically says the time that the sample was collected, or the date and time that it represents. A parameter code, which relates back to the parameter code table, and then a result code, or a result, which is basically a numeric of what was ever measured or simulated. And then if you want remark codes or qualifiers for anything that's coming out of the laboratory, you can also add a remark code. It takes at least this amount of information to define a data point in WRDB. All right, so now we're going to go ahead and download and install WRDB. If you go to Google and type in Water Resources Database, or just go to WRDB.com, you'll be brought to the website where WRDB is. Once you get on the website, there's a whole bunch of different information there, things that you may be interested in. There's some test projects that you can download and use. In our case, we're just going to go ahead and download, and we're going to download the most current developed WRDB, which you don't do from this screen, but you go down to all current and prior versions of WRDB 6.x could be found here. And if you go down all the way to the bottom, we're going to download the most recently released version of WRDB. which basically contains a bunch of bug fixes and enhancements that have occurred over the last year or so. You do not need administrative rights to install WRDB. It's going to go ahead and install the information onto your C drive as a default in a folder called Water Resources Database. You certainly can change where it goes. You don't need to make it go there. And then it's going to create some desktop shortcuts for us, which we'll probably be using a little bit later on just to make it a little bit easier for us. So with that, it's installed. So now it's just we're going to ask it to go ahead and load WRDB. Once WRDB is loaded, you're greeted with this screen here. There's a lot of useful information in this screen that will get you going. If you go through each one of them, it'll talk about how to create a project, how to import data, and then also how to select data, the different query options that WRDB has built into it, how to generate different reports based upon the data that you have, use the plotting utility, and then lastly, in the end, export data to other programs like Excel or what have you. I'd also like to point out, if you go up to the Help menu and select Documentation, there is a very detailed user's document in here that takes you step by step and gives you in-depth information on the inner workings of WRDB and how to use virtually all of its functions. With that, what we're going to do now is we're going to create our first project. So we're going to the File menu, set New Project, and then we're going to just give this a project name. And in our case here, it's just going to be ACWA Workshop. And then once we give this name, this is how you would find it when you go to load. We're going to select one of the database file types. In our case, we're going to select SQLite, and then we're going to select the directory and space where we want to store it. By default, WRDB is going to try to use your Documents folder in a subfolder called WRDB, and that's where it's going to create the actual file where information is stored. You do have to specify a master table. We won't be using any of them in here, but you have to select the time this thing is created. And once you're out of here, it's basically going to come and say, hey, we're going to go ahead and create a set of tables for you. They will be blank, and you should be good to go. Our next step is we're going to go ahead and create a working table. A working table would be, it could be based upon the subject or the content of whatever you want to import. But in our case here, we're going to create a table to import those USGS flow gauges that we downloaded previously with the R tool. And there's a lot of metadata that you can associate with anything that you bring into WRDB. So we give it a table name, we can give it a description, we can give it a source, and so on and so forth. Now, why is this important? Well, any of this information here that you can actually track it back in WRDB. So say that there was an error in your scripting tool that did something wrong. It would be easy to go query that data out and re-import. So next step will be importing. All right, our next step after creating the working table is we're going to actually import data from that NWIS R script that we ran earlier. One of the most powerful functions of WRDB is its ability to import data. So what we're going to do now is we're just going to take that data and bring it into WRDB. And to do that, it's just edit, import data, and it will open up a file dialog box and we'll pull in the things that we need. So we're going to bring stuff in for that station table that I showed you earlier. The P-code table and the result table. That's the only thing we're really going to worry about. So before we pull in the results, we want to make sure that we populate all the other information in the support tables for like stations and parameter codes. So the first one I'm going to pull in is the stations, and it gets loaded into this external. It's an external program that'll process the data, and basically it's mapping the column headers from that CSV file into the actual schema of WRDB. So it's putting the station information, the station ID, so on and so forth. So I'm going to hit continue, and it's going to say, hey, there's no real data here, so this must be support stuff. So we're going to pull that in. So now that data you can actually see here in the support table. All of the information that was made available from the NWIS server is put in here. Station ID, name, Latin longs, and the HUC that it belongs to. The next thing that we're going to pull in is the parameter code, and that says P code table. And again, it's going to just map in, and it's going to just bring in the two parameters that we downloaded, flow in CFS or CMS. And now they are mapped into the support table under the P codes. So the last thing we're going to do is we're going to actually bring in the flow data. And again, it's just edit import, and then we're going for results. And now you'll see that things will line up in here as well. We have our mandatory station ID, our date time, our P code, and then our value. And then we will pull this data into the working table. And you can say it takes a little bit of time because I think there's close to 98,000 records here. So there's our data that we downloaded now in WRDB. Okay, now we'll just look at some of the report functions that you have. So up underneath output, you'll have reports, and you can summarize this data by station parameter, parameter station. You can look at individual codes, so on and so forth. There are actually a bunch of different utilities here where you can actually do parameter statistics. You can actually compare measured data against numeric standards, and also do comparative. One of the first ones I'm going to look at is just called data availability, and it's just going to show us the basically by station and P code our availability. So wherever there's green, that means we have data. So real quickly, we can just visualize that for all of the stations that we downloaded, we virtually have no missing data. So that's one way that we can look at it. Another way we can look at it is we can just use one of the standard reports. So this is going to be stations and P codes. And again, it's just going to go select the data. And here are our stations. Here are our P codes. Here's our min, mean, max, and then our period of record that we have data. So there's all kinds of reporting functions that you can use. The other nice thing about it is you also can, when you run a report, you basically can hit copy, and then these reports would go directly over to WRDB or to Excel, and you could just paste them in. So it's got a lot of good functionality. Okay, so we just saw how to import data and to do a quick summary of the data. I'm going to close this summary. I'm going to close this temporary file down here. So the next thing I'm going to do is I'm just going to talk a little bit about querying. And that's the whole purpose of using a database system is you can store large amounts of data in here, but using queries, you can actually subset the data to things that you need. You can actually in WRDB perform a query and then send that information to another working table. So it may be just some way to cut down on the size and the time it takes to do stuff. So there's many different ways to query, but the two main ones I'm going to show you is binoculars, which is the advanced query, and then anybody who's really familiar with SQLite could use this one, where you can actually pretty much perform any SQLite function that you want, joining and unions and all that other stuff. But the one that most of us are going to use most of the time is just the binoculars, and it allows us just to query something that we need by just using a simple form. And one of the nice things about these queries is you can actually save them and use them later, or you can, it'll just remember what you did and bring it in the last time. So the thing I'm going to want to do is I don't want to do analysis both on the cubic feet per second and cubic meters per second. So what I'm going to do is I'm just going to say, hey, I just want to select all of the metric flows that are in the model. So I just click on the P codes, and it brings up this form. And again, these are the P codes that are in our support table up here. I pick Flow CMS, click OK, execute. So now all I have is, if I go to the stations reports, now all I have are the cubic meters per second for each one of our gauges. So that allows us to do some things a little bit quicker and not carry all of the data into each one of the functions. And the first function I'm going to want to show you is the graphing function, because it's a great way to look at your data and you can do it quickly. So the primary one that you're going to use is display time series. Now in WRDB, the graphing program and then the GIS tool that I'll show you later is actually separate programs, so the data is just passed from one to the other. So in our case here, you're going to get a form that looks something like this. So this is all of our data that we selected. So these are all of our gauges, and again, the only parameter we have over here is flow in cubic meters per second. But if we had other parameters, you can select it. And it's kind of real easy. You build a graph a line at a time. So I'm going to select a station, a parameter code, and I'm going to say add to left axis. And there is our graph of our flows at that station. And you can configure this program to look any way you want to. You can change the title by just double clicking on it. You can also change the units or the y-axis and just say flow cubic meters per second, so on and so forth. You have control over the legends. You have control over everything that you could want to control in a graph. You can. The background color, the grids, the fonts, the so on, and anything that you want. But this allows you to do multiple graphs. So I can go get the next one. So on and so forth. You can have as many as you want. You'll also notice that you can use two axes. So if you wanted to plot something against one another. The other thing is for series options, there's a couple of different ones. You can do time series. If you had distance data, longitudinal profiles, depth profiles, width profiles, you can do scatter plots, histograms, probability plots, so on and so forth. So if we wanted to do a probability plot of one of these flow fields, we would change this to probability plot. And at this point, I would just add a station, and then there's a probability plot, and you can see the flow at different points. All right, the last thing I want to just show you is the GIS component of WRDB, and I'm just going to give you a quick overview of it because we'll be, in my next talk, I will be showing it a little bit more, but we can do the same thing with that we just did with the graphing. What I'm going to do though is I'm going to go back, I'm going to select all the data, and I'm going to go to the GIS tool, and it's going to take all of this data and bring it over into a mapping tool. So you can see right here that here's our stations. This doesn't really mean that much, but we actually can bring in a base map here that'll show us where these stations are at. And you can see they're up in the Atlanta area here. And you can actually, let me just go ahead and zoom in to these guys. And then once we're there, you can see they're right here. You actually can use the select tool and select one of these stations. And if you look over here, you'll tell you what station, but you also can go ahead and graph right from in here. So that's that one station. So it allows you to look at where you have data geographically as you move down, and you can do comparisons. You also can have it show you, count wherever the dots are the biggest, you'll have the most amount of data. In our case here, they're all the same. So, and then you also can see the maximum flows. You can see the highest flow is down here. And if we go back to select and we hover over the station, it'll show up over here on the side. So it's a pretty good tool, and I'll show you how we use this with model data and model results a little bit later. All right, so the last thing I would say about WRDB is, yes, there's a little bit of a learning curve to use it, but I will tell you that any time that you spend learning this tool will allow you to organize, analyze, and share data with a lot more ease, and it'll definitely save you a lot of time. This next tool I want to share with you is called Power BI, and it's developed by Microsoft. The Power BI desktop tool is actually free to use and you can download it. One of the nice things about this tool is it has a vast array of import utilities to bring data into its visualization tool. And it also, in the crux of the thing that turns data around, is Microsoft's Power Query, which makes it very, very powerful. So what the tool really is a data visualization tool. It allows you to build comprehensive dashboards so that you can look at and evaluate any data that you bring into it. And it's a great way to share information with stakeholders, QA, QC data before it goes into a model. And as I told you, it can virtually connect to any kind of data source, and then you can visualize it in this tool. And the desktop tool is absolutely free. So what I'm going to do next is just share with you a couple of projects. Okay, I'm going to give you a demonstration of Power BI, and I'm going to actually pull in the same data that we used to download, that we downloaded with the R scripts from the NWIS site. So I'm going to go ahead and load Power BI. This is Power BI desktop, and I'm going to go ahead and use the get data function. And I'm actually going to go get those CSV files. So we're going to pull in the same exact three. We're going to pull in the P code, and then the stations information, and the actual data. So I see there's an issue here that it's not picking up the column headers. So I'm going to use the transform data, and I'm going to say use first row as headers. So that works. So that pulls that one in. So the next thing I'll do is I'll go get the stations information, and again it's just a CSV file. Go get the stations table. Let's go ahead and transform the data, just make sure that this one's okay, and we can see that the header came in all right. So we'll close and apply, and then the last one is we'll get the flow data from the CSV file. So that will be the results. And this one looks like it's fine, so we'll go ahead and load it. And it's pulled in all three of those. Now the nice thing about Power BI is because of the data, it's already recognized the relationships in this. So it's going to make it a lot easier to build a dashboard for this. We're going to build a quick dashboard. So we're going to have an XY plot on here. So I just click on XY. And I'm going to come over to my data fields. So my axis is actually going to be my date time. And then our value field will be the result field, just like it was before. And you'll see now we have a graph over here of that. So one of the first things is you'll notice that it's actually done sums over the years. You can see that it's set for summing. So I'm going to actually just drill this down, just using this drill down function to put in. So this is our daily flows now. Okay, so I'm going to actually go ahead and expand this a little bit more. The next thing we might want to do is we may want to have a map to go along with this. So we'll click on a map, which is going to be an Esri thing. In our case here, we're just going to go to our stations table, and we're going to get our lat and our longitude and put it in here. And now you can see our stations have showed up. So the next thing that we might want to do is we might want to have a filter for the parameter code. So we'll put a slicer in here. And then for our data field, we'll go to our P codes and drag our P codes over here. And now you can see our two P codes. And if we switch between them, you'll see that it actually switches. And then the last slice that we might want to have is just the ability to zoom these things in. So I'm going to go and add another slicer to the thing, which is here. And now I'm just going to grab my date time and drop it on here. And now we get a slicer that kind of looks like this little slider. I'm going to move these around. So now we can say, okay, if we only wanted to look at a shorter period of time, we can slice through it. So this just gives you just an idea of how you could do visualization. And I'm going to show a couple other examples. So you can actually flip between the P codes. You can actually select the stations here, and it'll switch between the stations and so on and so forth. So you can come up with a very informative dashboard to review your data. And I'm going to show you a couple examples in a second. All right, I'm going to give you a quick demo of two dashboards that were developed by Catherine York at the Region 4 modeling team. We use these to routinely review data for both point sources and weather data that we're using in watershed models. And the nice thing about it is once you develop these dashboards, they could be applied anywhere just by swapping the data out. So the first one's going to be a point source one, and just give you a flavor of what these things can do to allow us to analyze data that we're going to be ultimately putting into the model. So what we're doing is we're looking at point source data for, this happens to be in the Cape Fear Basin in North Carolina, where we're currently setting up a model. And this kind of just shows us the different facilities. And this is the counts of data that they have. And we can go by year, or we can actually do it for our whole modeling period, which would be something like that, and would give you all of them. Or we could do it specifically for a given parameter or a given permit. And just like I showed you earlier, you can also select them off the map here, and it'll show us what they are. So this is just like an overview of the amount of data. This shows you the average values for a given facility for a given year. And again, it allows us to do a comparison between years and facilities. And then you also have the ability to look at different graphs. So this is very useful for just triaging and QA, QC, and point source data that is ultimately going to be fed into the model. All right, the last one I'm going to show you is one that we use to analyze weather data that we download with the Region 4 weather processing tool. And again, this allows us to do a quick look to see where we have missing data, if there's any discrepancies with the given source of data. So I'm going to just start off with a summary of the data sources, and this is all the data that's being considered in this, what kind of station was used, and then a brief summary of each one of the stations. And we can do a quick annual review where basically if you look at any one of these things, that kind of represents the annual average rainfall. And you can see amongst the different data sources, sometimes there's just some discrepancies that we have to dial down into. And again, it allows us to look at individual sources. We could do it by month, or we could do it by year, by a given year. So that kind of gives us an overview of the kind of data that we have. And then you also could do a detailed review where you get into each one of the data sources, select what you want, and then you can actually dial into, in this case, the slider is letting us do month by month. So if that was your rainy season, you can see what the impacts are. If you wanted to go to a yearly collapse, it does a yearly collapse. If you want to go to daily, you can pick a day and it'll give you the results for the day. So this allows us to do a lot of filtering and digging in to check on where how the data is. I've given both of these dashboards. They're in my project files that are available for this class, so feel free to download them. All right, we kind of reached the end of our time here. I'm going to stop and take any questions. I want to just thank the Region 4 modeling team for all their support in developing the different scripts to kind of streamline our workflow. With that, here's the members of the Region 4 modeling team. It's Glenn Fernandez, Catherine York, John Davis, and Chelsea Weiskerger. With that, I'll take your questions.